So in this page, I'll be talking about Chadwick's discovery of the neutron. So James Chadwick was um, actually a student of Ernest Rutherford, and Chadwick actually took over Rutherford's research and studies a bit later in his life. And Chadwick's discovery of the neutron kind of marked the start of the modern era of study and understanding of the atomic nucleus. So, before the discovery of the neutron, atoms were thought to be just made up of two types of particles, protons and electrons. The protons were bunched up in an atom's nucleus, and the electrons orbited the nucleus. Now, in the early experiments, shows that the nucleus in a helium atom gave off exactly 2 times as much electrical force on an electron as a nucleus in a hydrogen atom. The only problem with this was that helium would then have 2 protons and 2 electrons, making its mass twice that of hydrogen atom, which has 1 proton and 1 electron. The reason that this was an issue was because in reality, helium has a mass 4 times that of hydrogen. Chadwick hypothesized that a helium nucleus had 2 more particles that were not discovered yet. He also thought that these 2 additional particles didn't have a charge because that they weren't attracted in any way to any sort of electrical force. Many other scientists kind of doubted Chadwick and thought that the particles he was talking about were just gamma rays. But gamma rays didn't have any mass, so this didn't make any sense to Chadwick. Therefore, Chadwick decided to perform an experiment. But, it's not like you can just go and put a subatomic particle on a scale and weigh it. So Chadwick had to come up with this ingenious way in which he could, find out what is now called the neutron and weigh it. So many nuclei of different chemical elements have had masses that were already known, and some already had special ways that you can measure the speed of a quickly moving nucleus. So Chadwick then set out to strike samples of certain elements with unknown new particles. When there was a direct impact between the unknown particle and the nucleus of one of the atoms, the nucleus would be hit out of the atom. Then Chadwick would record its speed. Now, in order to be able to conduct this experiment, Chadwick had to construct a subatomic pool table. In this apparatus, which is shown above or below, there is a disk of polonium. Now, polonium gives a source of radiation, which makes it possible to hit the neutrons out of the beryllium nuclei. The radiation given off by the polonium is absorbed by a few millimeters of air, and so that the air must be pumped out of the left-hand chamber. The unknown particles, now known as neutrons, strike matter more readily, and they shoot out through the wall and right into the right side of the chamber, which is full of both hydrogen and nitrogen gas. When a neutron strikes the hydrogen or nitrogen nucleus, it shoots right out of the atom with a lot of force. This nucleus then splits into thousands of other atoms of the gas. The result is an electric pulse that is recorded by the wire located on the right of the diagram. Physicists were then able to take the strength of the electrical pulse and make it into a measure of force. Chadwick conducted another experiment just like this one, but using nitrogen instead. With the information from these 2 experiments, Chadwick was then able to solve for the mass of the unknown particle. The particle's mass was less than 1% than that of the mass of a proton. Since the new particles were electrically neutral, he decided to name them the neutrons.